Good evening, everyone. My name is Samuel, and tonight we'll be discussing a particular concept in Python programming referred to as Python inheritance. So that's basically what we'll be discussing tonight, and I made an outline to discuss this concept. I have three particular sub-concepts I'm going to discuss. The first one being what we refer to as Python scope. Then we are going to quickly flip through Python classes, and we would now go into inheritance proper. So first and foremost, the first one here on the list is Python scope. When we are referring to scope, basically we are just talking about variables that we have in our Python script, or maybe in our module we might have variables. So what are the scope of these particular variables? That's basically what Python scope is talking about. And how can you access these variables? How easily accessible are they? Some variables you can access them, while some you might not readily access them, or before you can access them you have to call some special keywords in Python. So we have about three different scopes. The first one being the innermost scope. Then we have another one called the middle scope, and we have another one called the outermost scope. Actually, we have different sub-scopes, but I just grouped them into three. Inside each of these ones, we can have different sub-scopes, basically. So what do we mean by innermost scope? Basically, innermost scope could be, should I say, the most indented of any particular variable, or should I say function you might have, because in your Python module or your script you might have functions, you might have sub-functions, on and on. So the most innermost function, the variables of such a function, then you can refer to them as the innermost scope. Basically, we can use this particular methodology to describe innermost scope. And when we are talking about middle scope, we are basically discussing about those functions that are nested, that is variables that are in between your outermost scope and innermost scope. Those are the ones we refer to as the middle scope. And this middle scope can be divided into two. We have the non-local variables, and we also have global variables. So these are the two types of variables we can have here. For the middle scope, we can have non-local, and we can also have global variables. And for our outermost scope, this guy basically refers to scopes we have, or scopes that are actually built-ins, variables that are built-ins most times. That's what we refer to as our outermost scope. These are built-in variable names you can call anytime, anywhere in your script, or by default. When you have a Python script, these built-ins will be there by default. They are going to get your script is going to get the attributes of these built-ins like underscore name, or built-ins of that nature. And we are going to use a Python program to just briefly analyze this. We just want us to have an idea of what we refer to as scopes before we start classes and then inheritance. So let me just quickly show us. Okay, let me make a directory here and name it let's say inheritance. So let me seed into this directory. Let me seed into the directory from here as well, and then let me view into a file, and let's say the name of the file is scope.py. let's name it scope. Okay, yeah, scope.py basically. So we'll be defining some variables now, and we'll be telling us which one is at the innermost scope, which one is at the middle scope, and which one is at the outermost scope. So let's start writing something. I'm going to use declare a variable here. I'm going to name it glo_var. It stands for global variable. Let me increase the font of my terminal here. So let me name this guy I am global. So this guy is a string, and basically it has this statement. It says that what I am global. This is a global variable now because it is not defined in any should I say function. It's a variable that is defined in my own module. So we refer to variables as that, as global variables. It's not nexted in any function. It's independent of any function. So now I want to define a function here. I want to name it outer. And then inside this particular function called outer, I want to declare a variable. Let me call it outer var, just as an analogy. So I want to say I am a non-local variable. Let me decrease the font. It's already getting so I just declared a variable here and I called it I am a non-local variable. So the point is this: any variable you declare in a function by default, if you have something like a equals to 1, b equals to 2, these variables are actually local to this function. Basically, that is the convention. Any variable that is defined in a particular function is a local variable to such a function. But you might be surprised that why am I saying I am a non-local variable for this guy? It's because we need to, I want to declare another function that will be nexted inside this particular function. I just want to use it to explain the analogy of a global, a local, and a non-local. But if we have only this function here, definitely out_var is a local variable. But if we have a nexted function inside this place, then this guy, in reference to the other nexted function, we can't refer to this guy as a local variable. That's why I have this keyword here. But in fact, before I even go to the nexted function, let me rename this guy and say I am a local variable. Okay, I should just remove this one. I'm a local variable. Please give me some seconds. Let me quickly get to a quiet location. So here, this function is a local variable to this variable, I mean, is a local variable to this function. So here I can just print out my out_var. What if I want to, okay, let me come here and define main. Right, so what is our main function doing? Our main function is going to call this guy, which is called outer outer So it is going to call outer, and then it's going to print out the global variable. It's going to print out, no, let it just call outer. So here I'm going to call main, and after calling main, I'm going to print out global_variable. Alright, so let me save this file and let me Python 3 the file scope. And then on our screen, the standard output, we have a local variable, which is what this guy now we called main, and it is running our outer function, which is this guy. And then we printed out this variable. It says that what I am a local, okay, I am global, which is this file. We printed it here, even outside the main. In fact, this main function is kind of okay, it's almost useless, but then since I'll still have an inner function, so let me still leave it as this. Or no, let me take it off. I'll just call this function itself. Alright, so what if I want to access this global variable, this guy? Can I just say inside my can I say something like glo_var equals to I I'm accessing global variable. So if we do something like this, what is going to happen? Okay, no.
How else you define global again? What it means?
This one?
No, just like the name, as the name implies, global. Since you declared a global variable, what if you
Okay,
redefine global?
for this one.
Yes, like no, I'm not telling you to like reassign or redefine it. I'm saying what is the meaning of the word global?
Okay. What global means? Okay. Global variable is a variable that is not nested in any function. Like it's independent, it's outside of any function. Like this line 3 now, our out var is accessible from inside this function alone. Unlike this glow underscore var, it's not dependent or attached to any function. The namespace is in a module. And what is a module? Basically the file. So this glow underscore var, and what I'm trying to do on line 7 now should fail. No, in fact, it won't fail. It is going to just create a variable that has the name global, but which is only it is local to this function. So what I'm trying to do here is I'm creating a local function, right? So when I come here and I print out my global, and then in my function here, let me print out glow underscore var. So let me come here and call this function def. Okay, let me just call outer. So I called outer here and I printed global. This global will be this one, and inside this function it's going to print out outvar and it's going to print out global. So I'm just trying to show us that since we declared a variable here, it is local to this function, but this guy is it's a global variable, while this is a local variable. So when I do something like this, I save my file and I try to rerun. Okay, I'm having an error. It says that what name print. Okay, I think I made a mistake somewhere. Okay, let me save again. You can see it says that what I am a local variable, which is this guy, and it says I'm accessing a global variable, which is this guy, and it says I am global, which is this guy. So you can see that this global is different from this global, even though they have the same name, but they are actually two different variables. This particular variable is local to this function, while this variable is not attached to this function. The scope of this variable is not inside this function. It's actually the scope is dependent on the module, and the module is what our whole file. So what if you want to access a variable that is not inside your function? Then you have to use a keyword referred to as global. So you come here and say global, and then this statement now will now take effect. I am accessing a global variable, meaning you are trying to change a global variable. But without this global keyword, any variable name you define here, it will only be local to this particular variable. So when I run my file again, this is outer, I'm running this script. So by default, this global is accessing this variable, so it is going to change the value of this variable and it's going to print out this particular name. So before I even call my outer, let me print out my global, so we are sure that it actually changed the value. So let me come up here and paste this here. So I'm printing out global, which is this guy. Then inside this function, it's going to change the value of a global variable, and then I'm printing it out again. So let's do this, and let me rerun my script. Okay, it says that what invalid syntax there, global.
Yeah. I'm more concerned about, you already called it outside, and now you are assigning another thing to it. So
Line
which one is it
7.
supposed to pick from? And ignore line 1.
Okay. Okay, let me do something like this. Let me just declare here, and let me say glow underscore var equals to this. So let me do something like this. I'm declaring that I want to access this variable, then I'm now assigning from here. Let me try something like this. Okay, so yeah, I'm printing it out, which is this function, and I'm printing this out, then I'm printing this out. So let me rerun again. Okay, so it's printed out I am global, which is this guy, which is that's my line 12. Then my line 5 was executed and I have this printed out. Then I declare the global keyword to access a global variable which is outside the scope of my function, but I've been able to use the global keyword to access it. Initially I was accessing and initializing at the same time, then I have this error. It says that what invalid syntax. So maybe we would have to specify we want to access it first before we try to give it or reassign the variable. Maybe that's the error or the mistake I was making earlier. So after reassigning, I printed it out, which is this value. Now I am accessing a global variable. Then outside my function now, I printed the same variable out to show you that I'm outside, like I'm outside the scope of this function. This is my module, and I printed this out to show us that it's changed. So like I said, any variable you have is always local to any function. This is a function called outer, and this variable now is a local variable. But what if we now have inside this our function, we have another function that is a nested function? Then that is where what we discussed earlier we come in, which is what the one we discussed as the innermost scope, the middle scope, and also the outermost scope. We've not discussed about outermost scope. Outermost scopes are basically your built-ins, like I said, but your middle scope could refer to your, okay, we've not discussed about non-local, but we've discussed about global. So now let's go ahead and have a nested function. Then we'll now discuss about what we refer to as non-local and innermost scope. So let me delete this. I don't need to access any global variable from here. So let me just delete all this. Okay. So let me have it like this. So this outer val basically is just how will I put it? I'm just initializing a variable from there. So let me delete this as well. Okay. So let me have the nested function now. My def keyword again. This one now, let me name it inner, no arguments. So let me say local variable, local var.
Samuel.
Yes.
You start from where you wanted to click on your notepad.
I what?
You have to start from where you wanted to click on your notepad. Listing the variables, I mean the outer, inner, and your nested.
Okay, all these ones.
Function. Yeah, you're not sharing your screen first of all.
You've
been off for a while.
Wow.
Yeah, you've been off for a while. Because I'm saying you have to start from where you wanted to click on your notepad.
Okay. Thank you for that.
Right. Yeah, we can see your screen now.
All right. So I was saying, we've been able to discuss about global variables and also local variables. Innermost scope would always have your local variables, but local variables it's always in reference to another thing. Local variables basically. So in your innermost scope you would have your local variables, your middle scope you would have non-local, and you can have global. Then your outermost scope are your built-ins. So now with the nested function we want to write, would be using that to explain what we refer to as non-local basically. So I open this up. So I have this outer function. I deleted all what I have there before. I only have the outer function. Then this is my inner function that I'm writing now. So I declared a variable called local val. Then I said I am local to inner, meaning that this variable is local to this function. That's what it's saying. So we can decide to print it out. From this nested function, we can access this guy, just as we were able to access global from our outer function. We can access the variable in our outer function using our inner. Now, the idea is this. This variable outside here is a global variable. This variable outside here is not a global variable and it is not a local variable. It is in between. But the one here is a what? Is a local variable. So what do we call the variable here? We call it a non-local variable. So that's where the idea of a non-local comes in. You can just say a non-local var. That's it, a non-local variable. So now I want to have a print statement here. I want to use my f string, print f string, and I want to say something like printing then outer var, outer no, it's out var, printing out underscore var before modifying it. I can have something like this, and I can say where is outer var, which is this guy. Okay, so if you want to access this guy, you have to use the keyword called non-local. So like before, I will say non-local. You can see it's color coded to show that it's a what? It's a keyword. So I'm going to say non-local outer out var. What am I saying? Out var. Then I don't want to initialize because I have this type of error the other time. So I'm just going to declare it here. After declaring, then I will now initialize and say out underscore var equals to, then the initial name was I am a local variable. So I can decide to change it now and say I change to local. I can just have something like this. Then I can have my printf, my print statement again right here, and say after modifying it. So basically that's for that. Then from here as well, from this nested function, I can access the global variable. Now this guy and this guy, they are both middle scopes. It's only this guy that is like innermost scope. From what we've seen here, only local variables are referred to as innermost scope. And like I said, the keyword local is relative, because we can still say outer var is local to function to outer because it is only defined here, and we can say local var is local to inner, and we can say this our global variable is local to our module, like the whole script, the module. So using the word local, it's actually a relative statement. But for the context of what we are doing, let us just say this is the only local variable we have here, and let us say this guy is a what? It's a middle scope variable, and also this guy is a middle scope variable, even though it's like a global variable because it's outside any of the functions I have in my module. And the outermost variable now will now be your built-ins, things like underscore name and stuff like that, built-ins that come as a result of having a Python script. So I already used the non-local keyword, just like we accessed this. So I already changed this. Then I can change my global too. The same way, I'm just going to declare the global keyword and say glo underscore var, basically. So I can even say using my printf. Okay, no, let me do this. I want to say printing it out before modifying it, then printing it out after modifying it. The same thing we did here. Let me have a new line here. Okay, let me have a new line here as well. Okay, so let me have a printf Then here I'm going to print out glow underscore var after modifying it. Okay. No, this should be before modifying it. Before modifying it, then I will now modify it here and say glow underscore var equals to, and I can just give it a name and say global changed to local, something like this. Then I'm going to print out again and say after modifying it, then I'm going to pass in my what, my glow underscore var right here. Then I'm going to put my this thing here. Then basically that's just what we want to do. That's just what we want to do. So now I want this inner. I would want to call inner using my outer. So I'm going to come here and make sure outer as a function calls inner. So I'm just going to come here and say inner, inner, like this, opening and closing bracket to show it is a. So I'm going to come here and define my main and call outer. Then I'm going to call my main. After calling my main, then I'm going to print out global. Now this global I'm printing here, I'm doing it inside my module, that is outside any of the functions. So main, I'm calling main, and main is calling what, outer, and outer itself is calling what, inner from here, because this is outer, outer is calling inner. So let us see the flow of execution. So we are expecting our main function to call outer, and outer will start executing. Outer is not printing anything, it's just basically calling inner. Now it is inner that is doing the printing and even changing the variable of out var. So let me try and run. Okay, I have issues with my code. It says what, invalid syntax. That's line what, line 14. Global. I shouldn't have a bracket there because it's a variable, not a function. So let me interpret, or let me rerun my file. I still have another non-local out var. What's the name? Out underscore var. It says that what, out var is used prior to non-local. It's used prior to non-local declaration. That's line 10. So I'm having another error here. Okay. Out var, out underscore var.
No vex, I mean, look at the other side and solve this something. What's he do there?
I can't seem to figure out what exactly is flagging here, because I have out var here, and this guy should be a non-local.
See the line 10. It's flagging line 10. Name out var is used prior to non-local declaration. So you used it prior to non-local declaration. Are you supposed to still call it as a non-local variable, because you called the, maybe you don't need to call the non-local variable since it's inside.
If you want to access this guy, if you want to access what is here from inside this nested function, you'd have to use a non-looker, because this guy at this point is a non-looker. Let me change the name, and let me say outer double TR, then OUTTR. Okay, let me try something like this. Okay. I would have to change everything here. Okay. I think I know why it is flagging it. It's because I was printing before doing this. So I should bring my printf down here. I think that's the issue. Yeah, you can say something.
Yes.
So let me just
that
undo.
was what I was trying to say.
Let me just undo. So the problem should be from my print statement, not from the keyword. So let me just delete this guy. Okay, so okay, so I should print here, then I should change here. Okay, all right, so let me try and run again. All right, so basically it's doing what we want it to do. It says that I was printing I'm a local variable before I didn't even terminate that. Okay, so let me run to make it more readable. It says I'm a local variable, this guy, printing this guy before modifying it, and then printing I changed to local after modifying it. So where's I'm a local variable, which is this guy, that is outer, the guy that is outside here, the middle, what do we call it again, the middle scope. Yeah, the middle scope. We have non-local variables and global variables at the middle scope. So it's printed this guy. It was able to access this guy from this nested function using the non-local keyword. Then it printed it out, and it says after modifying it, it did that. Then we use global. Then we're able to do this just like we've seen from how we did it with this guy. Probably with that. So this is just like a simple analogy to variable scopes we could have in our scripts, and how you can access global variables, and how you can access nested, or should I say middle scope variables from inside nested functions. So this is just one of the 3 things we'll be discussing tonight. The second thing we should be talking about is the Python classes. So we just go through that briefly. Python classes. So let me veer into a file called class.py. So from our previous knowledge, we've been able to learn that classes basically are like the building block of object-oriented programming, and we've also been able to see that it allows us to build a template, or it's like a blueprint of what we want to structure, just like we would have a building plan for a building. So the same thing, we want to write like a program or a code that we would want to reuse in our program. We want to build a class for that, and we'd have to structure a template, and it can have attributes and it can also have methods. Basically, attributes are like the variables you would have inside your class, and methods are like the functions that you have defined inside your class. And to do that, we'd have to use a keyword called class. So you can just have a keyword called class, and you would have to give it a name. So the class could be anything. It could be anything. You can just have let's say class of students. This could be class of students. Then let's say pass. Let's just say pass. And here you want to initialize an instance of this class. Let's say let's just take a variable a is equal to student. Basically, you are calling this particular class here, this particular class you just defined here. You are saying that you are creating an instance, and an instance in this case is referred to as an object. That is the object of a class. And we already understand that everything in Python, they are all objects. Like everything is objects in Python here, meaning that when you have an object or instance of a particular class, it can potentially get the attributes or methods that are defined in this class. But here, this class is basically empty. It's not doing anything. We are just using this to demonstrate, okay, we can have instances of a particular class that we just defined here. So we can have attributes of this class. For instance, a student can have maybe a student would likely have a name, so we can say a dot name is equal to, let's say the name of the student is Jennifer. I don't know if this is correct spelling, but let's just go with this. So when we say name, that means name happens to be an attribute of A. And what is A? A is a class of students. That is an object of the student class, I mean. So we can go ahead to print out our a.name. And then it should give us something related to Jennifer. So let me Python 3 this guy and say class.py. And you can see that it's giving us this Jennifer. What if a student can have, should I say, a student could have something like ID card. The student could have what other things can students have? Let's say maybe a class. Okay, class is a keyword in Python. Let me just use the capital letter class. Okay, let me say department. Don't let me use class. Let me just say department. And we can go on and on like that to start defining. Maybe the student is a, let's say, a medical student, Department of Medicine, and maybe the ID of the student is, let's say, College of let's say CLI. Maybe the student has this matric number. Let's say the student got admission this year, that's 2023, and something like this. Let's say the matric number is 001 or something of this nature. Let's assume the student has this name, it has this ID, and it has the department called medicine. So you can see these are like attributes of this instance. The instance is what? The student. Then these are like attributes of what? Of the instance of this class. Then we can go ahead to print a.name, a.id, a.department, and it's going to give us all these things. So what if I want to have another instance? Let's say I have b equals to this, equals to student. Then I'll go ahead again and start saying b.name is this, b.id is this, b.department. You can see the stress. So why go through all this stress when there is something you can do to instantly, when you have an instance of a particular class, you can have all these variables instantly without you coming here to manually give the variables or passing the values to them. And that is where another function comes in. The function we refer to as init function. Init means initialization, so therefore when you have a function called dev, you pass in it 2 underscores and say init, then 2 underscores. And by default, this your init is going to take in an argument referred to as self. And what is self? Self is referring to this particular instance itself, like A. But you know, you can't know the variable name a user would likely use. So you cannot just come here and pass in A. What if the user is saying B is this student? We do not come here and change it to B. So you can't know. So that's why we pass in self like this. So when you pass in self, therefore, whatever option arguments you pass into this, your init function, we refer to it as methods. When you use dev keyword in a class, they refer to it as methods. So when other option arguments we pass into our init method could be name, ID, and department, and then we initialize it just like we did here. When we initialize it, that means when you have an instance or an object of such a class, by default it is going to get all these attributes instead of we manually typing it out. So here, let me just show you something. Print I am going to run. I just want to show you something that whenever you have an instance of a particular class, by default is going to call this your init method. Like, without you saying it, your init method is going to run. That is what it's for. Initialization. Immediately it has been created, init method will trigger and it will do whatever you ask it to do. So inside our init method now, which is a function, we have this print keyword. So when I try to run this my file, you are going to see that this would be printed out to the screen. You can see it's only one thing I'm printing. I'm printing out a.name. Then I'm not saying print init or anything like that, but it's going to work. Like by default, it's going to work provided you have init and you've already have an instance of a class. If you do not have an instance, then your init method will not run. But if you have an instance, init method will run. And how will it run? Because we are passing in self keyword. What is self? Self is what? The object itself, the object you just created, which is A. And if I have this two, it will be what? It will be B. So, and like I said, you can't pass in A here because you don't know whatever name or variable name your user would use to actually create an instance of a class. So, but when you use self, self is referring to the object itself that you created. And you can create numerous objects from a single class. Just like we said, it's a what? It's a template. So let me run this file. And you can see, it says that what I'm going to run. I didn't say this guy should run, but because I already have an instance of my class, so by default, init will be triggered. That is how your init works. So you can use this to your advantage, since you know that init will always run whenever you create a class, right? So, and then we want to initialize this particular variables for the instance of our class. And since we know an instance is what? Is self. So you can just go ahead and say self.name is what? Whatever variable we want to pass with. Self.id, self.department. Self can be anything. It changes, right? It can be A today, it can be B tomorrow, it can be any other variable name in the future. So we can use this to our advantage instead of we manually coming here to declare it one by one. And let me show you something. Here I have B equals to what? Student. Right? Simply because I have the variable name for A, an instance of A doesn't mean it is present in B. So let me come here and decide to print out print b.name. You are going to see the type of error I would get. Let me run. You can see that it says that what? Attribute error. Student object has no attribute name. This particular object, that's line what? Line 11. You can see it's actually flagging me here, line 11. It's saying that what? This student object has no attribute name because it is not what? It is not defined. So if I want to give it an attribute called name, I have to manually do it the way I did it here. You can see the stress whenever you create an instance or you have particular objects of your what? Of your class, you'd have to manually type the attributes you want to give it. But this your init, since you know it will run by default, why not you initialize here, right? So therefore, I'm going to come here and I'm going to pass in other arguments to my init and say it should take in what? Since I need a name, so it should take a name, ID, and also what? Department. In fact, let me remove ID. Let's just go with name and department. So I want to take off this line. I don't need this line anymore. So I can say my what? The instance, that is whatever object I've created, which is called self. By default, your interpreter knows what self is. It's a special word in Python. So I would say myself dot what? So I want to have name, right? Name equals to, it should be equal to what we have here, equals to name. So the same thing for my department. Self.department equals to department. So when I do something like this, instead of me manually coming here to declare them, whenever I create any objects of this class, by default, it's going to get these two attributes. Like it's automatic because you know it is going to run, right? So it's going to get it. So I don't need to come here and declare A.name is Jennifer and department and everything. I don't need to do this now. And I don't need to do that for my B student. Now, if I run this, I'm going to get errors. Why? Because, okay, let me run it first and we'll see the error. You can see the errors. It's saying that what? I'm missing two positional arguments. Meaning I'm expected to pass in two positional arguments. But right here I have 3. Why is it saying 2? It's saying 2 because this one is this guy. like we said, the instance you just created is yourself, is the self keyword, while you need 2 other arguments you need to pass in here. So I need to come here and pass in what? The 2 arguments. But if I do not want to pass in the 2 arguments, I need to come here and declare a placeholder. So here I can just say name is what? Is none. And department is none. These placeholders are just there in case nothing is being passed. Then I don't think it should flag and give an error. So let me go ahead and rerun. Now I'm trying to print b.name, even though I didn't pass in anything in my when I was initializing b here, creating the instance of a class called b, that has an object that has the class student, and I want to try to access it. Let us see if it is going to throw an error. You can see it didn't flag me, unlike before where I do not have any placeholders here. So basically what this placeholder is doing is that if you have nothing being passed, just give it this default value called none. So yeah, I decided to print out b.name, even though I didn't pass in the arguments that I'm supposed to pass, and b.name happens to be what? None. The same thing for a.name, it happens to be what? To be none. But if I actually do pass in something here, and let's say the name of, let me come here and say the name of student A is which name do we have here? Oh wow. Wow.
For it to be readable.
So I will come here now and say the name of the student is Matilda, and the name without a department. I'm not passing any department for this this second instance. Then the first one, I can come here and say white. Alright, so let us see the names it would print. So it says that what? Matilda and white, which is what? b.name, which is this object, and a.name, which is what? White. And let's try to print out let me use f string now, and so let's say we have something like name this, then on a new line I have department, then department.
No comma.
No, that's b dot department, like this. Yeah, it's because I'm using f string, so I don't need a comma there. So I'm going to copy this guy. I'm going to come here and do the same thing for this variable. It's only appropriate I even put it TSF just to make it align with that guy. So I'm going to change this to A, and I'm going to change this to A as well. Alright, so yeah, let's go. I'm going to clear this, rerun my script, and it says that what? Name is what? Is white, which is for the first object A that I created here, and it says department is what? Is none. Instead of throwing an error, it passed in this place value to it, even though I didn't specifically tell it the department, but it got this none. The same thing for the second one, Matilda and none. And if I happen not to okay, if I decide to pass in the department, let's say engineering, software engineering, and then we know what it is going to print out. It's going to give us the department as what? As engineering. So basically what this is just telling us is about what we refer to as the initialization method, that will always run. This guy will always run whenever we have it defined in our class. So moving on, we have some other methods you can have in your class which you refer to as functions, right? Apart from init, we still have other functions you can decide to write. This one is like a built-in function. You might have your own user defined function. Like this printing we are doing here, we can have maybe def let's just name it put car. Okay, that's not a keyword. Then when you are trying to define to write a function, you would want to pass in self as the first argument to it. Then you might decide not to pass in other arguments, but at least this yourself must be there. It must be there. So now let's make this function to print out what we have here. So we come here and then let me decrease the font. Then it's going to print this out for us too. Okay, yeah, we only need a single printf, so I can just delete this and I can delete this as well. I don't need a print statement. So this is a function now inside our Python file called putCar, and let's just say this function wants to print out the self.name and the self.department. Like we said, self is the instance. So instead of me passing in a here, you already know what I'm going to pass. I'm going to pass in what? Self here, right? Because I'm going to pass in self, and for department I'm going to pass in self. It should change to self because self is the instance itself. It can be this guy, it can be this guy, but if you use the keyword self, it's going to access A as self, and here B is going to become self. So that's basically what I'm trying to do there. And when I call this function, that is the only time it is going to trigger. So I already have my instance here to be what? To be this guy. So coming here to my line 11, I can now go ahead and say a dot. I want to access this particular function, or we call it method. So I can say a dot putCar. It takes in no argument. So when I do this, it is going to trigger this function, and then it's going to do this, right? So the standard output. So when I save my file and I recompile, you can see it's printed out what? The name, and it's printed out what? The department, which is for this guy. I only called this particular method for the instance of my A. I didn't call it for B, so that is why B isn't doing anything per se. I didn't call this method for it. If I want to call this method, then I would have to specify and say b.putCar. But your init method, you don't need to call it. I don't need to come here and say a dot underscore underscore init before it would run. All these variable assignments would be done by default, like we explained earlier. Init will always run as long as you are initializing. As long as initialization is taking place, then it means init is what is taking place. But this one is not a standard function. It's like a user defined function. So I'm telling it to do something. And before I can access the self.name, because name is not defined here, it is defined inside this instance. So I have to pass in self here. In fact, by default, you have to pass in self. So it is this self that I'll use to reference the self.name and self.department. You know, we discussed about scopes when we started. So when you want to reference what is outside a function, you can use your what? Yourself to reference a variable that is outside this function. Now, these variables now, they are not local to this function. We are only referencing a variable. We can even say it is global. Or no, don't let us use the global keyword. Let us say these functions are non-local. We can use the word non-local to this particular function. So moving on, I can go and declare a variable that is local to my function. Inside this my function now, I can have a word, let's say okay, let's name it here we have department, we have name. Let's just name it school. Let's just name it school. Now this word school is only accessible to this function, not to this init per se. So that means when I want to call this function, I have to pass in a what? This argument. So let me save my file and let me see the error message I would get. It says that what? It requires a positioner argument, which is what? My putCar. That means I have to pass in the word, the school name, when I want to call the putCar here. So I can pass in the school name and pass in photo like this, and then I will save my file. But then let us allow it to print out this photo. So it is going to come here, name, then where I have my new line, school, this is my printf. I should do something like this, school. So I use the backward slash here. I believe this is going to escape the space, the spaces I have here. So this is school. I don't know if this will work. I've never done this before, but let it print out. Now, how will I access school? How will I access school? Can someone tell me how I can access this school? Like I want to print out school. So what am I going to pass into my curly braces here? For name, I pass in self.name. I use that to reference it from here. Then for department, I pass in self.department. So I can now print out this school, which is this guy. How can I do that? What am I going to pass in here?
Self.school. I'm not sure though.
Self.school. Okay, let's try that. Self.school. Alright, so let us save our file. And let us see if it is going to run or it's going to give us an error message. Okay, we have an error message. It says that what? Attribute error. It says that student object has no attribute school. So what exactly is it saying here? It's saying that student, which is this student, it has no attribute school. So what is happening here? What are the attributes of this student? There are only two. It has a name and a department. Attributes are like when we're doing our A, something like this, we did a.name. So these are like attributes, and instead of manually typing it, this guy is doing it for us, right? But here there's nothing like a.school here, so that is why it is giving us this error. This school argument is only for this function, not for the instance of this particular variable per se. So this school argument or variable, it is local to this function called putchar. It is not for the instance of the class, or should I say the object instance. That's why I started this session with the concept of scope, just so when we get to this point we will not get confused. I already explained the concept of scope earlier. If you weren't here, you can still go through the recording when we are done with the session, then you understand exactly what we mean by saying school argument here, or this parameter is local to this putchar. It is not actually defined here. It is not defined here. So that is why it is telling us that it has no attribute called school. So therefore, when I want to print out school, I don't need to pass in self. I just need to print out school, just like you would print the variable for any function. I don't need to pass in self. I just need to remove that and pass in school. Basically, that's what I should do. Okay, I need a new line here. Printf. Yeah, I need a new line. /n, then /n. Yeah. So let me print that out. Class.school. Oh wow. It says name white, school photo, department engineering. Which kind of printing is this? Anyways, so it says the name is white, the school is a photo, and then the department is engineering. Okay, let me do this. Let me see. Ooh. Okay, let's see. I just want to see the type of output. Okay, it's now aligned. Name white, school photo, then department engineering. So this is just explaining to us that this school is actually for this function. If you want the school to be an instance now, what can you do? You just need to come here and say you now initialize, just like you would normally do a.school like this. You normally do a.school is equal to then what's the name of the school? Photo. just like you would do this, right? So you can come here and come and initialize, but you have to initialize inside your function because the school is local to your function. You have to initialize inside your function. So you come here and say self dot school, which is self dot this variable. Self is what? The instance, which is a dot what? Dot school, which is this guy. Is the same thing. A dot school is the same thing as self dot school. Then you can now say is equal to what? Is equal to school. So when you do this, now you can now print out this guy using your self keyword, just like you asked us to do earlier. So when we do something like this, self dot school is now going to work. It will not say it has no attribute called you can see that, right? It's not going to say object instance has no attribute called school. Why? Because we specifically added a new attribute at this point. So you can see you can initialize from here and you can even initialize from here. But if you know you are not initializing here, you don't need to print with a self dot method. You shouldn't do that because it's not going to work. It's going to tell you this instance has no attribute called school. So that's for the difference between attributes that are defined inside our init method and attributes of a function, like other than your init, that is the methods you have. So you might have a lot of functions inside your class, like a lot of them, and if each of those functions are getting parameters that are not defined here, right, you just need to come here and if you want to, it's not compulsory, if you want to, you can initialize the instance of such an object to save or have an attribute that you have inside your function. Depends on what you want. So moving on again, what else do we have? Let's see. So yeah, we've discussed about classes. Just the brief summary. We aren't discussing like in depth.
Back to your script. You have to do a dot putka and a dot school at the same time. Can't we go with one since we've already declared it?
Okay, yeah. I was only using this as an illustration. We can delete that. The code is still going to work.
Okay.
Let me rerun. It's still going to work. Thank you for that. Okay. Now let us go to inheritance itself. That's the last thing we're discussing for tonight, which is inheritance. So basically, the concept of inheritance comes in when you have obviously this is a template, and we've discussed that everything in Python, they are objects, right? Objects are just instances of classes. So this is an object, this is another object. You can have a lot of objects, and they will always get a particular class. Like they are going to be instances of a particular class. When we are now talking about inheritance, here we are basically saying whenever you initialize or you have the object of a particular class, then it is going to get the attributes. It is going to get the methods of such a class. This is what we are saying. Let's say you have A equals to what? ABC. What is ABC? ABC is a string. Now let me print out the type of A for you so we see. Print out type of A. So let me run this file. You can see it says that what? Class string. So str is a class, and when we are printing the type, it's telling us that A is a what? Is of type string, meaning from the class string. But of course we know that what? A is a what? Is an object of this particular class called string. And by default, A would have methods. You know, inside our class, we have attributes, we have methods. Methods are functions, basically. Like this guy now is a method. Putka is a method of the class student. So that's why I was able to use a.putka here. because I initialized a to be equal to what? To this class. The same thing here. A is equal to the class called what? String. So therefore, I'll be able to use a dot whatever method that we have inside my class called string. So when I type a dot, you can see a lot of methods I can use, like functions. You can have a dot capitalized, like anything. You can see by default it's going to get such attributes. This is where inheritance comes in. It has inherited the methods, the attributes of this class string that we have here. It has inherited it. That's why I am able to actually access this method that is being printed right here on my screen. I don't need to come and start defining a function called count before I can use it on my a string, because by default, when I have an instance of such a class, the instance of such a class, which is called an object, is going to inherit all the properties of such a class. So let me just demonstrate this by using count. Count basically is just counting how many times a particular character appears in my string. So let me come here and say a like this. So let me come here and count a. So I can print that out, print out the count of a. So when I run my script, it says that what? I have a 19 times inside this script. You can see that this method is like a useful method, and it's something you might likely use in real life. Like you might want to see how many times a particular alphabet occurs or something like that. And you have this by default because of inheritance. Because of inheritance. So when I have the particular object of type string of class str, it's by default has all the methods we have in str and the attributes. It has inherited it. So by ourselves too, we can see now that inheritance can allow for code reusability, meaning you can reuse your code. Basically, you can reuse functions that are defined inside a particular class because of what we refer to as inheritance. You don't have to come and start rewriting such codes or such methods. And now let us try to bring this home practically by actually writing a code. So I'm going to exit this file via into a class called inheritance. Inheritance.py. So now we've been able to discuss about scopes. We've also been able to discuss about classes. Now let us go to inheritance briefly. So we'll be creating a class here. Let's have a class again and let us name it. Okay, now we have ALX program, which is what most of us here are currently doing. We have the program called ALX, and then we also have a community referred to as CodeTrybe. Now if we are to look at it very well, it's highly likely that without ALX, CodeTrybe will not exist, because CodeTrybe was born out of the existence of ALX and because of the software engineering program. So we have a community of learners who decided to come together, and then the community CodeTrybe was formed by our president, Top Man Paul DK. And you can see that somehow CodeTrybe has borrowed some attributes of ALX. For instance, ALX started what we refer to as PLDs, that is PLNE days. And now in the CodeTrybe community, we are doing that regularly. It wasn't like our own idea, it was the idea of what? ALX program. And then we've adopted it as part of our own, of what we do here as a norm. The class str has this count defined in it. A adopted or inherited this particular method. The same thing, ALX started PLD and CodeTrybe adopted it. So now let us write a class of ALX, and let us also write another class of CodeTrybe, and let us try to define some methods inside the class called ALX, and let CodeTrybe to actually inherit some of the properties. And I believe that should make more sense as regards the concepts referred to as inheritance. So briefly, let us write a class called ALX. So as usual, we'll be defining our underscore in it, because we won't want to come down here and say A is equal to ALX, then we'll start say A dot something. We don't want to do that. No, we don't want to do that. So let's define our init, and let's say we would have in ourselves, then we'd have name, something like this. Let's say we'd have name. Then something I didn't mention is this. Okay, let me still go on. When we get to inheritance, then I would mention some terminologies, but let me still go on. So yeah, I would just say myself.name is equal to what? My name, which is this variable here. So I'm initializing name to be whatever self.name happens to be. So in CodeTrybe, in ALX, I mean, the person would likely have a name, maybe a student that is enrolled in this program, this free program, this scholarship. The person would likely have a name. Let me see, am I still on the call? Okay, I'm still on the call, just checking. So the person would likely have a name, right? Whoever is enrolled in this ALX software engineering program.
Yeah.
Then the person would likely have, let's say, a cohort as well. You remember now, this is a function that we are writing, and by default, we would always want to pass in the first, the instance of the particular object. That is, when we are creating an object from this class, we want to pass in self as the first argument to this guy, which is referred to as a method. So I want to pass in myself at this point here. Now let's use the positioner placeholder that we mentioned earlier. This guy basically is just checking for the person's cohort, and let us allow it to print it out too. So this one is for name, then this is for cohort. So yeah, let me come here. So in case if the person doesn't pass in name, so let's just say, okay, let it fail. If there's no name passed to an instance, let it fail. There's no need coming here, let it just fail. So for cohorts, I can say cohort is equal to let's say unknown cohort. So this is a method inside my class called ALX to check for cohorts. Then I would want the instance to have this particular cohort, just like we did earlier. Matilda, I believe you are still here with me. So we are just going to say self.what cohort.
Yes, sir.
Equals to cohort here. So
I
basically,
never abandon you. Yeah.
You said?
Go ahead, son.
Yeah.
All right. I believe this line makes sense to us why I'm trying to do this. I want the instance of this, whatever object I'm creating from here, to have a variable called cohort in it, because this cohort is local to this particular function. But I want my init method to have it. That's why I'm manually saying self.name is equal to cohort. Self.cohort is equal to cohort here. So whatever instance I create would have this particular guy. That's when you actually pass in a cohort. So I have this.
Carol's hand is raised.
Okay, someone's hand is raised. You can.
Yes, I wanted to tell you that before you run the program, remember to include a colon at the end of the class.
Okay, thank you.
That's right. Debugger.
Thank you very much. How am I using Prince F?
God, we should just send DM after the class. We should have been a debug.
So I can say name.
No problem.
Just like we did. Okay, let me remove this. Just like we did earlier. So the name, I want to access this guy now. So I can print out myself.name. I can print out myself.name. Then after printing out the name, then it should print out the cohort as well. So I would add a new line here. And then I can say cohort. Then because I already initialized cohort.name, so I can just print out self.name right here, close my f string, and here we have it. So after printing this out, I want to print out a new line, so let me just add my print statement here like this, something like that. So this is just getting the cohort for any object of this class. So someone in this ALS program can have a name, the person can have a cohort. Let's say the person has a nationality too, maybe a country or something of that nature. So let me say nationality, let's have something like this. So self, let's say, let me come here and say, okay, let's just say origin. Let me pass in origin here, the person's origin. So this function or method called nationality is having one positional argument, or one argument, which is what? Origin. So this self will be passing by default, right? So I can come here if I like and still say that my self dot origin is this. I can decide to initialize that, and I might decide not to do that. Okay, let's print out without saying self dot origin is this. Let's print out. So let me grab this. It's not compulsory you do this all the time, like this your self dot cohort. So let me grab this. Oh wow. Oh, in fact, I shouldn't have done that. Let me just undo what I did here. Oh boy, what did I do there? How can I redo what I oh my god, so I'm typing all over again.
You can use escape and U.
Yeah, that's what I did, and it's taking me backwards actually. I want to redo. Let me just retype it quickly.
Escape and colon redo. Type redo.
Okay, redo like this.
Yes.
Already at new exchange. Oh wow. Okay, I think I've not got a lot of choice here. So I want to print out name, self dot name, then a new line, then cohort like this, then what? Self dot cohort, something like this, then close the F string, then I define nationality, nationality, then self, then I said origin, no position argument there, no place value. Oh, this. Then I said I want to print out without actually say I don't want to say that self dot origin is equal to origin. So I just want to print out. So let me use my F string here and say something like name. Should I print out name here as well? Okay, let's print out name, sha. Okay, I should have a new line here. I did print out a new line here earlier, so let me print a new line here. So we'll be able to differentiate between cohorts when we call cohort and when we call name. So let me come here and say name. Then as well, I'm going to pass in myself dot name, then a new line. So origin. Then here now, I can't say self dot origin because this is going to complain that this my object doesn't have the attribute called origin. So I just have to print out origin like this. You can see what we are doing here is different a bit from what we are doing here as regards the print statement. Oh, I'm using print.
Your print statement as printed.
Yeah, thank you for that. So now the person can have a cohort, a nationality. Okay, let's stop here.
Why are we using our origin with a capital O?
Is it here or here?
The first origin, yeah. Why are we using capital?
Yeah, this one is just a print statement. This is the real
thing. Yeah, it's just a print statement, like a tag.
Yeah.
A tag for it.
Okay.
Just like I use capital C for this guy too. So let's go ahead now and try to obviously when we have an instance of this class, it's going to work. So now let's have another class called CodeTrybe now, which is going to now inherit attributes that we have defined inside ALX. So let us have CodeTrybe. So by default, when you want to inherit something, it follows this format. You are going to your class keyword, then this guy is referred to as the derived. Okay, let me type that somewhere here. They call it the derived class or the child or the subclass. And this guy at the top that you are inheriting from, you will refer to this guy as the base class, or you can call it a super class, or maybe a parent too, or a parent class. Oh, why did I see? Let me just put a single S. I don't want it to go to a new line. So something like this. So this guy is a base class, or maybe a super class, or a parent class. You can refer to it using those names. Then this particular guy called CodeTrybe, which you want to inherit from ALX, you refer to it as a derived class, a child, or a subclass. And how do you inherit? Basically, inside our class, we are going to pass in the name of this class we are inheriting from. So I'm going to pass in ALX like this, and something like this. Wow. Okay, should I come here? Let me come here and okay. So I hope this it won't flag me. So inside this place now, I can just pass in pass, basically, just to like demonstrate for us if truly ALX CodeTrybe can access the like the functions we have here and the methods. So let's go ahead now and create an instance. Let's say student1 is equal to, so I want to have an instance of this class ALX. So I'm coming here to say ALX. Then obviously if I do not pass in the name, my program will crash. So let me just pass in a name. So let's say we are using Rosina.
Samuel, maybe your screen. Okay.
Yeah, it's missing. So let's say we are passing Rosina here as the name for student1. So of course, here quotes, I can use my student1 object to access this method. So I'll say student1 dot, we use the dot notation to access that. So I want to say the quotes, I want to specify the quotes. So how many arguments? It takes in 1. Even if I do not pass it in, it's still not going to fail because we already passed in a placeholder. But then let us put in the quotes. Let's say quote 14. Let's assume Rosina is in quote 14. So let's do something like this. And then we still have our nationality. So Rosina student1 dot, that's nationality. Okay, so the one dot nationality South African. So yeah, something like this. Now this is for the class, our base class, which is called ALX, right? So now let us initialize with CodeTrybe now. Another student with CodeTrybe. So let's say students, in fact, can I just copy, let me save this file and let me tail it out and just copy what we have there, because if I copy from my Vim, it's going to give me all this new line nonsense. So this student2 now, student 2, student 2. So let's say the student 2 is Aisha. Aisha. Then let's say she's in cohort 10, and let's say she's a Nigerian. All right. So inside our CodeTrybe class, we didn't write anything. Pass is just like a placeholder too, just so the class is not empty. But then we already specified that we want to inherit all what we have in ALX from here. We already specified that. And just like we saw from when we created an instance of our class str, right? It inherited by default the methods we have defined in str, which is count, just one of it. We have a lot of methods for our class str. So the same thing is going to happen here. We already have an instance of class CodeTrybe, and class CodeTrybe is inheriting properties that we have in ALX. So that is why we are confident that this code should run. So let us see if we are not going to get errors, and let us try to see the output of the code. So let me run Python 3. Okay, it's printed out something to the screen. So I think it's working. It printed out name. Where do we have name? Okay, yeah, it printed out name and cohorts. Yeah, that's line 7. Then this print is the new line that we have at this particular point. Then our nationality printed out okay, name. It printed out name, then origin too. Where is it? So why is it printing out? Let's see what happened there.
Samuel, you called what happened? The name? Go on.
Let's see. Something happened here. This is Rosina and cohort 14, which is supposed to be this guy, right? Then a new line. Then again, nationality, name. We printed out name and origin. Okay. Yeah, this is its name and origin. Okay, I'm supposed to put a new line here too, so that's why it's kind of confusing me. I really want to differentiate between the first one and the second one. That's why I decided to put a new line there. Okay, I think this would help me to differentiate better. So I can rerun now. Yeah, so it is printing out in batches of 2. So this is for the first one, which is cohort, right? This is for cohort. Then the second one is for nationality, which is this one, the name and the origin or nationality. Then now, this worked for these two guys. Coming on to ALX, a student of ALX, then we have the same thing as above, the name and cohort, also the name and nationality or origin. So this is just like the simplest level you can ever get for inheritance when you are trying to actually inherit from a class. You are going to specify the name of the class you want to inherit from, then your statements. You can have statements inside your class. So I'm not saying you pass. There are some things here you might not want to inherit, or you might want to have your own. Maybe for cohorts, you don't really like what cohort is doing here, or maybe you want to modify your own. Here, you can come inside line 16 and below and define your own cohort, or stuff like that. Okay, in fact, let us do something of that nature. How we can modify our own methods, and this is it. By default, when you try to modify a method from the inherited class, you modify it inside your derived class. The method you just modified is going to get assigned to the derived class. Let's say you modified cohort here and you have cohort here. So by the time you are calling the cohort, like the instance, it's going to get assigned, or it's going to be is the cohort you have defined in your derived class that it is going to use. It's going to discard this one, meaning that methods here, if the name of a method you have in your derived class is clashing with the name you have from your parent or the base class, the one in the derived class will take preference over the particular method you have in the base or parent class. So let us go ahead and try to do like some minor modifications to this particular code. So let's come to ALX now, to CodeTrybe I mean. Let's come to CodeTrybe and let us try to have our own instance. So the first thing we should pass in is self, right? So we should have our self. Now let's say here we have self, we have name. So let's say we want to have self, name, and also let's say language. Now you can see it's a bit different from what we have here. This one is having only 2, whereas we want to have like 3. That should be 2 arguments, compulsory arguments you must pass here combined with self, but this one is only taking 1 compulsory argument, right? So we can have something like this. It's not that your function must always your base class must always have the same pattern as your parent class. No, the derived class can I mean, it's not always a rule that your derived class must always have the same pattern as your base class. You can always adjust your derived class the way you want it, or what you want to do. Depending on what you want to do, you can always modify your code to suit that. So we would want to actually initialize just like we normally do for all our init processes, right? So that when it runs, it's going to get initialized. So we can say self.name equals name, then self.language equals to language. So here it's showing us that our init can be different because we do not have, let me put the comments here. Init can be different. Let me put the comments here. Yeah. So in our code, here we have our init. We already defined our init to be a bit different from what we have at the top. Then here we have cohort, we have nationality. So let us define our cohort and let us make it in such a way that it's not going to work like this one. Let us make our own cohort to work in a different way, and let us see if when we call this our CodeTrybe object, like when we create an object of this CodeTrybe and we call this method called cohorts, which I'm about to write inside, let's see if it is going to use that of the inherited base class, or it is going to use the one that is local to it. Let us do something like that. So let me create another cohort and I'm going to modify it. It should not be what I have here. In fact, don't let me put any arguments here. It's not taking in any arguments. Let's just say it's printing out something to the console. So I want to use my f string. I believe I'm still on the call. Okay. So I want to use my f string, and let's say it's printing out something like I don't have a cohort here because it's not taking any argument. I don't have a cohort, but I speak. Then you should say I speak whatever language we are passing in. Now let me come to the top here, and okay, I think I have it. This guy, I want to reference this guy. I was thinking I will still come here and do my self.language, but I already have it here. I don't even have the language as an argument here. So I'm just going to reference it directly from here because I've passed in my self keyword here. So I'm going to say I speak self.language. Even though this might not be making a lot of sense, but it's just to demonstrate that you can have your a clashing method with the inherited method to do something completely different. That's just what I want to prove here, and then we are going to see which one we take preference. So I should terminate this. Okay. So it has init cohort. So let us try and run it now before I modify nationality, because we are still going to do something else. Let me print a new line here as well. Okay. So let's see, where did we initialize CodeTrybe? CodeTrybe. Where are you? This ALX. Wait, did we use ALX both times? Oh, we're supposed to use CodeTrybe, and I used ALX. No. We're supposed to use CodeTrybe for the second instance. I didn't even know I used ALX.
That was for the first instance. Now you used ALX for everything. No. I'm not sure you used ALX. Maybe you just added that. You called directly.
I thought I used CodeTrybe. We're supposed to use CodeTrybe. Wow. It's supposed to be CodeTrybe because we are demonstrating. Okay. So here we have ALX as the class, and here we're having CodeTrybe as the class. And then we still want this guy to access what we have. So now for cohorts, I'm passing in an argument. So you should throw an error because cohort here is not actually supposed to have an argument. That's for CodeTrybe. It's not supposed to have an argument. So if I should run now, it should actually flag me. So I'm going to delete that. Cohort is not taking anything. That's for CodeTrybe because I just modified the code. In fact, let me undo
It won't be like
this. No, let me just remove this. Let us try because we did not use code. What is this thing doing? I want to comment out this guy. Okay, so it's almost as if we have only this guy here. I want to be sure CodeTrybe is working. So our function is basically the same, just that I initialized okay, let me pass in my pass keyword that I have here before. Okay, so here I only have pass. That's all. Okay, so let me see. Okay, so now we use CodeTrybe on line 30 as against ALX we used for both previously, but now we've changed it to CodeTrybe, and it's still giving us the same output: name, cohort, name, origin. Then this for CodeTrybe now: name, cohort, name, origin. So just to show it is working, it's like he inherited all the attributes of ALX. CodeTrybe inherited all the attributes
as an argument.
Exactly. So now I'm going to remove the pass I have here and uncomment everything I have.
Okay, maybe we should stop there for now. Let's run the first argument, the first method, and see.
I only have 2. Now for this init, I need to pass in, because this is taking 2 positional arguments, like 2 compulsory parameters, name and language. And here I'm only putting in name, so I have to come here and pass in my language. So Aisha speaks what? I believe Yoruba language, if I'm not mistaken. So let's see. Cohort 2, I should delete that because it's not taking any arguments. Okay, the nationality is still going to get inherited from this. Alright, so let's go and let's see if we are going to get errors or not. Wow, we have errors. It says that what? Line 18. Where is line 18? Self.language. Okay, I think indentation error there. Okay, it's this guy self that is wrongly indented, and it's the other one that is being flagged. See life. Okay, it says that name is Rosina quote 14, then name and origin. This for ALX, which is this line 24 to 26. Now this says I don't have a cohort, but I speak Yoruba language, which is line 19, which is cohort, right? That's line 29. It says I don't have a cohort, but I speak self.language, which is Yoruba. Okay, I didn't put language at the end, but okay, I speak Yoruba. We have cohorts here. Both methods are clashing, the inherited one and the one defined locally in this function. But we can see that the one defined locally has preference over the inherited one. So that's one thing about inheritance that we need to take note of. But while the third one, nationality, we didn't actually define any method for it inside our base and inside our derived class. So by default, it's going to inherit the properties from the base class, and that is why it is still printing out what it would normally print.
Yeah. Okay. So because of the method, yes, the method is defined inside of CodeTrybe for cohort. It has a what's it called? A parent method that is for cohort already.
This
So
one.
what you're saying is yes. What you're saying is it substitutes the. Is it substituting the first method that is being inherited with the normal, with the one down there on line 19? It substitutes line 19 to 21 with line 15 to line 5 to 8 rather.
Yes, because both are clashing. Cohort is a method here, cohort is another method here. So whenever it has a method that is defined in it clashing with a method it inherited, it's going to discard the method it inherited and go with the one it has in it. That's if they are clashing. But if they are not clashing, then it is going to pick up the method it's inherited, basically. Now, this our cohort now, we did it in such a way that it is completely different from what it inherited. What if we want to define our own, let's say, cohort, and we still want it to inherit the cohorts like the one that is clashing? We can actually have both together. It is possible. Not that whenever it's clashing, it has to pick one over the other. You can write your code in such a way that it is going to have both methods, like the one it inherited and the new one it wants to define. It's possible. And I think this is the last thing we'll be doing for this session. But we will not demonstrate that with cohort. Let us demonstrate that with nationality. That's why I did not write anything for nationality. So I'm going to come here now, and we are going to actually do that for nationality. So def nationality, and for this one here we have self, we have origin. So for this one, let us say we want to have self, this one origin. So let's say we want to have city, maybe the city of the person, and also nationality. Okay, does this make sense? Then let's print out then nationality is defined where okay, let me just print out. I don't need to say self.city, self.nationality. I'll just print out directly. So once again, I'm going to print out name as usual. So self.name, then name is what? No, I should say name like this, name this, then I should add a new line here, then print out city like this. So here, instead of doing self.city, because I haven't initialized that, so I'll just print out city. This variable is only local to this function called nationality. So I would add a new line again, and now nationality is the third one. Nationality. So as again with this, I didn't initialize that, so I'm going to do that from here. Okay, now our nationality as against this is taking only to self and origin, but this one is taking in self, city, and nationality. I can change this nationality to origin. It depends on what I want, but since I want to inherit this as well, so I wouldn't want it to clash, so I'll just leave this as origin, and then I will have this as nationality. So that's why I'm having nationality. So if I want to have my own local nationality defined here, that is my method, and I also want to inherit that of this guy as well, then I would need the help of a particular syntax called super. This function called super. So when I call super with my open and closing bracket, this super can help me to reference the methods I have in my base class or my super class or parent class. From the word super class, then you use the word super to show that you want to access the particular variable, that is this guy. You want to access it from here. So I'm going to use my super with my dots. Super dot what? So then I can now come here and pick whatever instance I want. I can pick what? I can pick anything I want. But here we want what? We want nationality. So I'm going to pick nationality. So it's just as if I'm calling this guy. And how many arguments? This guy needs at least one, right? It needs one argument. So I will come here, use my super keyword, then nationality, which is this method I want. I'm calling it inside my the local nationality method that is here, and I'm referencing the inherited nationality. So I'm going to come here, super.nationality, then I'm going to pass in something inside it because it needs at least one compulsory how will I put it, argument. So here we have self, we have city, we have nationality. So I can go ahead inside here and pass in this argument inside it. At least it needs something that I must pass inside it. So I can decide to pass nationality. Yes.
And please, on line 24, use printf instead of print.
Okay.
Allow Samuel breathe. Allow Samuel breathe.
Thank you. And funniest thing, inside C, I'll be using print. In Python, I'll be using printf. I don't know why it happens like that. So, yeah.
I think Rosina's hand has been up.
Okay.
Yeah, that was
okay.
Java will be console or something.
Referencing. We are referencing inherited class. No, inherited method. Let me add a slash, then enter. We are referencing inherited method from inherited method using super function proly or super method. I don't know if this is going to flag me. See, let me just put hash here because I'm not sure. So what did I just type here? Super is going to pick up the base class, which is the nationality I have here, and because I need to pass in at least one argument, so that's why I need to just pass in something here. So I decided to put in nationality here. So it's going to call this guy and it's going to print out what we have here, followed by this new line. So the first print statement will be this, then this city, then nationality. Since I'll be printing nationality here, then I can just decide not to print it here, so I wouldn't have to print it twice. So let me delete it from here. There's no need to print nationality from here. Let this guy print nationality for you, since there's a there's a print statement inside the nationality here. But just that it's going to reprint the name and origin. In this case, origin is what our nationality. All right, so that's for that. Let us try and save this file now. Okay. Nationality 2 arguments. That's for CodeTrybe. So how many am I passing? Nigerian. So I need to pass in the city first, right? So let me come to this place. Aisha, you're in which city?
You can use Ilorin.
Aisha, you're close to Ilorin. I'm in Ilorin too now.
Okay. So that's
but I thought you said you were Ghanaian.
Yes.
Or you were Ghanaian living in Nigeria.
So let's see. Nationality, I want to be sure. the first one is city followed by the nationality, this and this. So now this nationality is now what we are passing into the nationality inherited class we are referencing using the super method, which is this guy. So this guy is going to help us print it out followed by a new line. So yeah, I'm only printing out name and city. All right.
So, Mr. Samuel, which one do you, before you run the code, before you run the script, which one do you think is going to come out first? The city or nationality?
You should follow this order. Since this is the first print statement, then followed by what I'm referencing. So it is going to check this code, this particular line, then to go here and access what we have here. After doing this, it's going to obviously to terminate from there because I don't have any other statement here. So I feel name should print followed by city. Then after city, another name followed by nationality, then it should end. But let's try that out. Okay, the first one is for ALX, name and quotes, which is this, right? No, which is where do we have it, sir?
Yes, for quotes.
Name and quotes,
ALX,
which is this guy. Then the next one is name and origin, which is what we have here. Then this one is I don't have a quote, but I speak Yoruba, which is our quote here, which is like the one local to this function. Then lastly, we have our nationality. So the first one it is called in here. The first two here is actually our line 24, which is name and city. Then the last two print statements here that we have on the output is actually the one we are referencing inside our derived class. So we are referencing the base class or the super class using the super method. We are calling it, and then it's going to come here and it's going to do what we asked it to do, and then it's printing a new line. The program ends. So this is like a brief concept of what we refer to as inheritance. There are still a lot of stuff there actually that I'm not mentioning, like a lot of stuffs and types of inheritance. Like while I was going through this, I discovered a lot of things and I was like, wow, if I should discuss these things, I'm just going to confuse everybody here. And I will end up confusing myself too because I still need a lot of time to like go through these different types, and we still have a lot of things under inheritance. But this is just the basic. If you understand this, then you'll be able to build up on this to like even do more complex things than you having a single type of inheritance. You can inherit a lot of things at once. Then you know the order of preference for each of the base classes you are inheriting, because here on line 15 we only have one base class. You might have like 2, 3 or 4. That one is what we could refer to as multiple inheritance. Then they have the, should I say, rules that we would have to take note of. But without knowing this single inheritance, how would we know the rules that are guiding multiple inheritance? We still have hybrid. We have a lot of them, like different types of inheritance basically. But this is like the general concept or what we need to know as regards inheritance and how you can reference a particular method and how you can even change your own method. You don't want to use the method you're inheriting. You can change your own method and define it to mean another thing, and on like that. Do we have anyone who is like confused with what we've done so far, or who needs clarification to a particular thing we've discussed right here on the call, or maybe any addition or subtraction?
I want to add a new line. I want to add a new line to the code.